Hey guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 136. Single number. Given a non-empty array of integers num, every element appears twice except for one. Find the single one. You must implement a solution with a linear runtime complexity and use only constant extra space. Fine. Let us ignore that constraint. We just follow this question alone at first. Okay. So in this question, they have given that every element occurs twice in that array, but only one element occurs once. So how to find that element? Let us take an example. Just take 2, 3, 3, 2, 1. So 1 is occurring at only once. So output will be 1. So how to predict it? How to do this? So my first approach is a brute force approach. A brute force approach. What is my brute force approach? I know. I can traverse this whole array, right? First I take this 2 and check whether this 2 is in this array except that index, right? Except that index, whether 2 is there in this array. Yes, that is 2. Now take this 3, whether 3 is there except that array index. Yes, it is here. Okay, now take this 3, whether 3 except that array, except that index. Yes, there's a 3 here. 2, that's a 2 here. 1, there is no one except that index, right? So this is the brute force approach. So I'm just traversing through all the array elements, For each array element, I again traverse through all the array elements and check whether the current element and in this array element is same or not. So it is a brute force approach. So what is the time complexity and space complexity? The time complexity is O of n square, whereas space complexity is O of 1. Fine. Let us see the code first. Just see here. This is a code for I in range of len of nums. For j in range of len of nums. If I is not equal to j and nums of I is equal to nums of j, I just break. Okay. Else is for this for loop. If this for loop runs successfully without breaking, then this else part will be executed. In this else part, I will return what? Nums of I. Fine. So this is the code. This is the brute force approach. Now, how can we optimize it? In this, they clearly stated that all elements occurs twice. Only one element occurs only one time, right? So we are counting, right? So shall I take hash map? Because it is counting, right? So shall I take hash map? Just take the same example, 2, 3, 3, 2, 1. Now I am taking a hash map. Inside that I am just mapping every element and its count. So 2 is occurred twice, 3 is occurred twice, and 1 is occurring one time. Now again traversing through this hash map and checking whether this 2 is occurring twice. Yes. This 3 is occurring twice. Yes. This 1 is occurring once. So this should be my answer. So output will be 1. So this is my second approach. So what's the time complexity and space complexity? Space complexity will be O of n, because we are using a hash map. And what is the time complexity? Time complexity will be O of n for traversing to every elements, and to use the hash map, it is log n. To insert the element, we use hash map, so it is log n. So this is the time complexity. Right? So this is the second approach. Okay. There are n number of elements, and every element occurs twice, and only one element occurs once. So can I use set? Okay. Let us take in set. We have two functions, right? Add and remove. Add function and remove function. Let us take 2, 3, 3, 2, 1. Here is my set. Now insert this 2 in my set. Yes, insert this 3 in my set. Again, there comes 3. Now remove this 3. Because 3 is already in the set, right? Again, 2 is coming. Already 2 is in the set. Remove it. 1 is not there in the set. Add it. Now, at last, only one element will remain in the set. Just return that. Return the remaining element. In the set. Right? So this is my approach. This is my third approach. Okay. Talking about the time complexity and space complexity. What is the time complexity and space complexity? Time complexity will be O of n for iterating every elements in the array into log n for inserting and removing the array elements, set, right? For adding an element in the set and removing an element in the set, we use log n, right? So what is space? It is O of n, because we are inserting into the set. This set will take space of O of n, right? So this is the third approach. Okay, fine. If we sorted the array, if take for example we have sorted the array, then our array looks like every similar element will comes next to next, right? Just take for example, it is 2 3 3 2 1, right? I can take 1 2 2 3 3. Now I can say for this two, my neighbor, if any one of my neighbor is same, it is not my answer. Yes, correct. So take for example this one, whether this one has a neighbor which is equal to 1, no, right? So this should be the single element, right? Take for example, if the sorted array is 2 2 3 3 4 4 5 6 6, right? Now for this 2 we have a neighbor 2, for this 2 we have a neighbor 2, right? Again for this 3 we have neighbor 3, for this 3 we have neighbor 3, right? Again for this 4 we have neighbor 4, for this 4 we have neighbor 4. Now important note is coming, right? See here, for this 5, take this element and take this element, whether the two are same, no, right? This 5 is not equal to 6, this 5 is not equal to 4. So I can say this 5 is a single number, so I can return the 5, right? So this is the fourth approach. What is time complexity and space complexity? Time complexity will be, initially I am sorting, so it will be n log n. Using the bed sort, initially I am sorting, so it will be n log n. Okay. What is space complexity? It is n, because in med sort it uses auxiliary space. So it is n. Fine. Okay. Still can we optimize? Since in question, in problem statement, they have given don't use extra space. So it means the space complexity should be O of 1, right? And they are asking us to do in a time complexity of O of n, right? So can we do it? Let us think. Take this. If I can do in any operation, like if I can nullify, that is, if I can remove this and this, my remaining element will be my answer, right? So by which operation we can remove two similar elements? Let us think about it. I know for sure that 2 XOR 2 will be 0, 3 XOR 3 will be 0. So anything x which is XOR x will be 0. Doing same number XOR will result in 0, right? Okay, fine. This is my first observation. My second observation is 0 XOR x is equal to x, right? Anything XOR 0 will be anything that number, right? So by concluding I can say that the whole array I want to do a XOR for this whole array to get the output, right? Take the same array. Now take this 2. Take this 2. Initially my XOR value will be 0. 2. 2 XOR 0 will be 2. Right? Again take this 1. 2 XOR 1 will be 3. Now take this 2. 2 XOR 3 will be again 1. Because 3 XOR 2 will be 1. Right? Again take this 3. 3 XOR 2, sorry, 1 will be 2. 2, right? Again 3 XOR 2 will be again 1. So 1 is a single element. So return 1. So return x. Fine. So this is the step. I can take this and take this. While doing this both, it would nullify, because doing the same number XOR will result in 0. This and this. So at last this will be my output. So talking about the time complexity and space complexity. Tell me, what is the time complexity and space complexity? Time complexity will be O of n, right? Because we are traversing only once this array. Then space complexity will be O of 1. Right? Again, I want you to understand a sixth approach, a bonus approach, which is quite interesting, right? It is interesting approach. Interesting approach. Interesting approach, right? It is interesting approach. Just listen to it. First I will sort the array. Let us take a sorted array is like this. Let us take a sorted array is like this. Now can I do binary search on this sorted array? Whenever there is a word called sorted, we always use a binary search approach, right? We always use binary search approach. Okay. Take the middle element. Take this middle element. Middle element is 3. So let me put the indices 0, 1, 2, 3, 4, 5, 6. Right? Now take this middle element. Now where is the pair of my middle element? My pair of this middle element is it in the right side. It is in the right side. So I can say here are 2 pairs, and again I have to have 2 pairs here. Currently my element should have pair in its left side, but it have a pair in right side. So I can say I want to move to this part of the array. I can eliminate this part of the array. Right? So how can I do this? If the mid is odd, okay, in this scenario here it is odd, right? It is at the odd index. If it is in the odd index, and also mid plus 1 is equal to mid. This both value are equal. I have to move where? I have to move this u pointer to, sorry, this upper limit pointer to here, right? So upper limit pointer to here, right? So I can put like u is equal to mid minus 1. Fine, understand? Mid minus 1, right? Now this is my first scenario. Let us take like 1, 2, again 2, right? 3. In this scenario, let us take mid is here. So indices are 0, 1, 2, 3, 4. It is at the odd index, and its similar element is in the left side. So if it is the mid is in the odd index and element is in mid side, sorry, in the left side, it is at the right side, right? It is at the right side. Now it is at the left side. If it is at the left side, then mid minus 1 is equal to mid. Then where I have to move? I have to move to the right part of my array, right? I can eliminate this left spot. So I can say L is equal to mid plus 1. So this is my first approach. This is my first logic. Fine. Now let us take another example, like 1, again 2, 3, right? Let us assume here is my mid. whether my mid have any similar value in neighbors, any similar values. No, right? No, right? In this scenario I have to return my mid. So it is the starting case. It is starting case in which, so this is my first case. This is my first case. And my second case is my mid will be not equal to mid minus 1 and also not equal to mid plus 1. I can say like this. So at this time I have to what? Return. I have to return the mid value. Right? This is my second concept, second logic I have built. Now let us see the third logic. We have already seen the when the mid is at a odd. Now when the mid is at a even, let us take when the mid is at a even. Let's take this. Indices are 0, 1, 2, 3, 4. Now let us take mid is here. Mid is here. Now mid is where? Mid is at even. Mid is at even. Now whether my similar element is in left or right. It is in left, right? So it is left. So mid is equal to mid minus 1. So it is at what? Left. So where I have to move? I have to move to left side, right? I don't want to move to right side. I want to move to left side. So to move left side, I want to shrink my upper limit to mid minus 1, right? This is my first case. And what is my second case? Mid is equal to mid plus 1. Mid plus 1. That is take for example 1, 1, 2, 2, 3. In this scenario, my mid is here. If my mid is here, where should I move? I want to move here, right? Because here there is no single element. Here only there is a single element. So when this mid is equal to mid plus 1, I have to move my left pointer to mid plus 1. Right? Fine. So this is my approach. So combining these three, I can now write a binary search algorithm. Right? So these are the 6 approaches. So talking about this binary search algorithm, time complexity. Let's take here. What is the time complexity and space complexity? Time complexity will be n log n because we are sorting initially, right? So n log n, and space complexity will be O of n. But still, what is the purpose of using this approach? Purpose of using this approach in this problem is quite not efficient, right? But if the problem is like they will give you a sorted array. Where every element occurs twice and only one element occurs one time. In that scenario, this approach will falls on a time complexity of O of log n, while space complexity will be O of 1, constant time. So this is the beauty of this binary search approach. If you don't understand this binary search approach, please watch again this binary search approach. You can understand, right? So let us see the code. See here, this is the brute force approach. Now I are going to see about the hash map approach. See here, I am declared a dictionary. Then for I in nums, if I is not in dictionary, I will take it as initial value as 1. If it is at the dictionary, I will increment the value as 1. For I in d dot keys of, if d of I is equal to 1, if the value is equal to 1, I want to return the key, right? So this is the dictionary approach. Just I can run it. Yes, it is submitted successfully. Then now we are going to see the set approach. Let us see the set approach. In set approach, we will just traverse to one by one in nums. Then if that element is in set, I want to remove. If it is not in set, I want to add. And at last I will return the remaining only one element in that set. So I have used the pop-off function. So let me run this. Fine, it is submitted successfully. Now the fourth approach is I want to sort every elements in the array. Then I have to check whether a element is equal to this nearest element is not equal to previous element and not equal to next element. If it is the case, I want to return that element, right? That's a single element. So see here, if len of nums is equal to 1, I will return that nums of 0. This is edge case. In this problem, I have faced so many edge case. So be careful. Put this condition. Then if nums of 0 is not equal to nums of 1, then I can return nums of 0, right? If the first element is not equal to the second element, then I can surely return that first element, right? Because first element don't have previous number, right? If the last element is not equal to the second last element, I can return the last element, right? Now, for I in range of 1 to len of nums minus 1, and I'm checking the condition like if the element is set a I index, it don't want to be equal to the I plus 1 and it don't want to be equal to the I minus 1. In that scenario, I will return the nums of I, right? So this is the fourth approach. Let me submit it. Yes, submitted successfully. Now, fifth approach is XOR approach. See here, only 4 lines. X is equal to 0 for I in nums. XOR is equal to I. So I am going to take every element XOR and I am going to return X, right? So let me run this. So this is the optimal approach for this problem. Fine. It is running successfully. Now, the last approach, this is the important approach by using the binary search. Binary search approach is so much important. Why? Because according to this problem, it is n log n because of sorting. But if the problem statement is like they have given the array in a sorted order, then it will be running in the most efficient way than the all other 5 problems all other 5 approaches, because it gives the time complexity of O of log n and space complexity of O of 1. So it is a most efficient approach, right? So see here, nums are sort of, I have sorted the array, len of nums is equal to 1, then return the nums of 0, right? If nums of 0 is not equal to nums of 1, I want to return nums of 0, right? If the last element is not equal to second last, I want to return the last element, right? Now, I just initializing L as 1 and U as length minus 2. So, the lower limit and upper limit. Now, L is less than or equal to U, mid is equal to L plus U divided by 2, right? I am just finding the mid value. If you are using C++ or Java, don't use this formula. Instead of this, you can use like L plus U minus L and divided by 2. So because you at maximum values, you can reach some integer overflow error. But in Python, it don't show that error. So in Java and C++, use this formula, right, to find the mid value. If nums of mid is not equal to nums of mid minus 1 and nums of mid is not equal to nums of mid plus 1. So it is not equal to previous element and also the next element. In this case, I want to return the mid value, right? If mid index is even, I said you earlier, right? If mid index is even and the mid element is equal to the previous element, I want to shrink my upper limit. Right? Else I want to shrink my lower limit by 1. Increase, right? Else in this case, like the mid index is odd. It is odd index. I want to check whether nums of mid is equal to nums of mid plus 1. If it is so, I want to shrink U, the upper limit. Else I want to shrink the lower limit by incrementing by 1. Right? So this is the binary search approach. Let me submit it. Yes, it is submitted successfully. So these are the 6 approaches you have to note in this problem. Thank you.